Hello everyone. In this lesson, I will solve the ministerial equation of finding limits numerically. But before I start the questions, I'll give you this note. For a trigonometric function, limit sine ax over ax when x approaches to 0 is 1. If the coefficient of x is equal, then the limit is 1. Also for tan ax over ax when x approaches to 0, the limit is 1. Limit 1 minus cosine ax over x when x approaches to 0 is 0. Whatever the coefficient of x here inside the cosine, it doesn't affect by the limit. It's always 0. Number 2, limit x approaches 0 for sine ax over bx, the coefficient change, then the answer is the coefficient of x in the sine over the coefficient of x in the denominator, a over b. Also for tan, the same. Limit x approaches 0, tan ax over bx equal to a over b. Limit x approaches 0, sine ax over tan bx equal a over b. Number 4, limit x approaches to 0 for ax, negative or positive sine bx over cx, negative or positive sine dx equal to a plus minus b over c plus minus d. Number 5, limit x approaches 0 for sine ax minus or plus sine bx over cx, it's a minus or plus b over c. The final rule, limit x approaches to 0 for sine square x over x, it's equal to limit sine x approaches to 0 for tan square x over x and equal to 0. The ministerial question. Number 1, find the value of the limit x sine 1 over x when x approaches to 0. We will find, since when you substitute directly every x with 0, it will give you sine 1 over 0. It is undefined term. Then I'll try to find this limit numerically. I'll find several value for x when it's approach to 0. I'll take 2 over pi, 2 over 3 pi, 2 over 5 pi, 2 over 7 pi, 2 over 9 pi. As you know, the graph of sine is periodic. Its range is from -1 to 1. When x is pi over 2, the value of sine is 1. When x is 3 pi over 2, the value is -1. Now, 1 over 2 over pi, it is sine pi over 2. Sine pi over 2 is 1. When x is 2 over 3 pi, then sine 1 over 2 over 3 pi, it will be sine 3 pi over 2, it is -1. And so on, sine 5 pi over 2, it is 1, sine 7 pi over 2, -1, and so on. As you see, the limit oscillated between 1 and -1, two fixed number. Then The answer is not exist. The right answer is the limit not exist. It is oscillating between two fixed numbers. Question number 2. Find the value of the limit x approach to 0 for cosine 1 over x. Also, if we divide 1 over 0, it is undefined term. Then I'll try to find it numerically. xy. Here I'll take 1 over pi, 2 over pi, 3 over pi, 4 over pi, 5 over pi. The graph of cosine is like this. Also, the range is between -1 and 1. The value of 0, 1. The value of pi, -1. The value of 2 pi, 1, and so on. 1 over pi. Cosine 1 over 1 over y is cosine pi. Cosine pi is -1. Sorry, I'll take 1 over 2 pi, 1 over 3 pi, 1 over 4 pi, 1 over 5 pi to approach to 0. We want x approach to 0. 1 over 2 pi, it is cosine 2 pi. Cosine 2 pi, it is 1. Cosine 3 pi, -1. Cosine 4 pi, 1, and so on. And as you see, the limit oscillating between two fixed points, -1 and 1, then the right answer is not exist. Number 3, if limit f of x when x approach to c is 2 and limit g of x when x approach to c is 3, then find the limit of the product of f of x and g of x when x approach to c. This limit is equal to limit x approach to c for f of x times limit g of x when x approach to c, equal to this limit is given by 2 and this limit is given by 3, and the answer is 6. Number 4, limit f of x when x approach to c -3 over 4, limit g of x when x approach to c 2 over 3, find the limit f of x plus 2g of x. This limit is equal to limit f of x when x approach to c plus limit 2g of x when x approach to c, equal to, this limit is given by -3 over 4, and this limit is, we can write it as 2 times limit g of x, it is equal to plus 2 times 2 over 3, it is 4 over 3, equal to, common denominator 12. 12 divide 4, 3, 3 times -3, -9. 12 divide 3, 4, 4 times 4 is 16, equal to 7 over 12. 7 over 12, choice B. Question number 5. If the limit of f of x when x approach to c is -2 over 3, limit g of x when x approach to c is 5 over 4, find the limit when x approach to c for 2 f of x plus 3g of x. I can rewrite this limit as 2 limit f of x when x approach to c plus 3 limit g of x when x approach to c, equal to limit f of x when x approach to c is -2 over 3, then 2 times -2 over 3 plus 3 times limit g of x is 5 over 4, equal to -4 over 3 plus 15 over 4 equal to 12 negative 16 plus 3 times 15, 45 equal to 29 over 12. 15 minus 6, 9, 3 minus 1, 2. Then the right answer is C. Number 6, f of x equal 2x power 2 minus 3x plus 1. G of x equal cube root of x plus 6. Find the limit of the composite function g of f of x when x approaches to 4. This limit I can rewrite it as g limit of f of x when x approaches to 4 equal to g of limit f of x, it is 2x power 2 minus 3x plus 1. When x approaches to 4 equal to g of 2 times 16, 4 power 2, minus 3 times 4, plus 1, equal to g of 2 times 16, 32, minus 12 plus 1, equal to g of 32 minus 12, 20, 20 plus 1, 21. G of 21, it is the cube root 21 plus 6. It is cube root 27. It is 3. Choice D. Question number 7. Limit f of x is 27 when x approaches to c. Find this limit. Limit, I can rewrite this limit as equal to limit x approach to c cube root f of x square equal to cube root limit f of x square when x approach to c equal to cube root limit f of x all square when x approach to c equal to, the limit is 27, then 27 power 2 cube root. I can rewrite this as 27 2 over 3 equal to 27 1 over 3 power 2, 27 cube root of 27, 3 power 2 is 9. The right choice is C. Question number 8. F of x equal 5 minus 2x and g of x equal x power 3. Find the limit of the composite function g of f of x when x approaches to 1. Rewrite this limit as g of limit x approach 1 for f of x equal to g of limit x approach 1 for f of x for 5 minus 2x equal to, substitute every x with 1, 5 minus 2 times 1, 5 minus 2, it is 3. Then g of 3. G of 3 equal to 3 power 3 equal to 27. Choice C. Question number 9. F of x 1 over 2x minus 6, g of x square root x minus 2. Find the limit of the composite function. Rewrite this limit as f of limit g of x when x approached 3 equal to f of limit g of x is square root x minus 2 when x approach 3 equal to, substitute x with 3 minus 2, 1, square root 1, 1, then find f of 1. f of 1 is 1 over 2 times 1 minus 6 equal to 1 over 2 minus 6 equal to 1 over negative 4 or negative 1 over 4. Choice B. Number 10, f of x 2x squared, g of x, x minus 3. Find the limit of the composite function. Rewrite the limit as f of limit x approach 2 for g of x equal to f of limit x approach 2 for g of x, x minus 3. Then substitute x with 2, 2 minus 3, negative 1. Then find f of negative 1. f of negative 1 is 2 times negative 1 square equal 2. Choice C. Question number 11. f of x equal 5 minus x, g of x equal x cubed. Then find limit for the composite function g of f of x when x approaches 1. Rewrite this limit as g of limit x approach 1 for f of x equal to g of limit x approach 1, f of x is 5 minus x equal to g of 5 minus 1, 4. g of 4 is 4 power 3 equal to 64. Choice D. Question number 12. f of x equal to x power 3 minus 3x minus 1. g of x equal cube root 5 minus 2x. Find the limit of the composite function g of f of x when x approach to negative 2 equal to g of limit x approach negative 2 for f of x equal to limit g of limit x approach negative 2 for f of x to x power 3 minus 3x minus 1 equal to g of 2 negative 2 power 3 minus 3 times negative 2 minus 1 equal to g of negative 2 power 3 negative 8 times 2 negative 16 negative times negative positive 6 minus 1 equal to g of negative 16 plus 6 negative 10 negative 11 negative 11 substitute in g equal to cube root 5 minus 2 times negative 11 equal to negative 2 times negative 11 positive 22 plus 5 27 cube root 27 it is 3. Choice D. Question number 13. f of x equal 2 over x squared, g of x equal negative 2 over x squared plus 1. Find the limit of the f of x plus g of x when x approach to 0. If you find the limit separately, you see 2 over 0, it is undefined, and 2 over 0 square also it's undefined. Then I'll try to find it. I'll try to add f of x to g of x and then find the limit. This limit will be limit x approach 0 of f of x 2 over x squared plus g of x negative 2 over x squared plus 1 equal to limit x approach 0 of x power 2 common denominator 2 minus 2 plus x square equal to 2 minus 2 x square with x square, limit of 1 when x approach 0 equal 1. The right choice is B. Number 14, f of x 1 over x, g of x 1 plus 1 over x. Then find the limit of f of x minus g of x. Also, the limit of f of x separately is 1 over 0, and also g of x contains term 1 over x. Then I try to find this limit together. The limit will be x approach 0, f of x 1 over x, g of x is 1 plus 1 over x equal to limit x approach 0 of 1 over x minus 1 minus 1 over x, 1 over x with minus 1 over x, then limit x approach 0 for negative 1 equal to negative 1, choice B. Number 15, f of x equal 4 over x power 2 minus 4, g of x equal 1 over x minus 2. Find the limit of f of x minus g of x when x approach to 2. Also, if we take it separately, 4 over 4 minus 4, 4 over 0, 1 over 2 minus 2 also is 0, then we will find it together. Limit x approach to 4, f of x 4 minus x square minus 4 minus g of x 1 over x minus 2 equal to limit x approach 2 of, analyze the denominator of the first fraction, difference of 2 square x plus 2 minus 1 over x minus 2. Then the limit will be limit x approach 2, common denominator x minus 2, x plus 2. For the first fraction is 4, for the second fraction is x plus 2 equal to limit 4 minus x plus 2 over x minus 2 x plus 2 equal to limit negative x 4 minus 2, it is 2, it will be x minus 2 over x minus 2 x plus 2, x minus 2 with x plus 2. The answer will be when x approach to 2, negative 1 over 4, negative 1 over 4, choice B. Question number 17, find the limit when x approach to 0 for f of x. It is piecewise function and 0 appear in 3 segments. I take it from right and from left. If the limit equal, then the limit exists. If the limit not equal, the limit not exists. Limit x approach 0 from right. When x greater than 0, then x minus 1. 0 minus 1 is minus 1. When x approach to 0 from left, it means x less than 0. I take negative x plus 1. Negative 0 plus 1 is 1. Since the limit not equal, then the limit not exists. Question number 18. F of x equal x power 2 plus 4 when x less than or equal 1. 2 minus x when x greater than 1. Find the limit when x approach to 2 from left. 2 belong to this interval since it is greater than 1. Then I'll find this limit as limit x approach to 2 from left for 2 minus x, substitute this segment, then equal to 2 minus 2 equal 0. Choice A. Also, if the question asks you to find x, limit x approach to 2 from right, also it is 0, since 2 belong to this interval and it doesn't belong to this interval. Question number 20. F of x equals 3x minus 2 when x less than or equal 1, 4 over x plus 1 when x greater than 1. Find the limit when x approach to 1 from right. 1 from right, it means when x greater than 1, then I substitute in this segment, then the limit when x approach to 1 from right, f of x will be 4 over x plus 1 equal to 4 over 1 plus 1, 2, 4 over 2, 2, choice B. Question, I'll return back to 25, 21. Find the limit x approach to 3 for x minus 3 power 2 over x power 2 minus 9. If you substitute directly, you will find the answer is 0 over 0, but if we analyze the denominator difference of 2 square, then we get x minus 3 times x plus 3. You can reduce x minus 3 with x minus 3, then the limit will be limit x approach to 3 for x minus 3 over x plus 3. Substitute every x with a 3, 0 over 6 equals 0. The limit is 0. 22, x approach to negative 5 for x plus 5 over x power 2 minus 25. If you substitute directly, you will get undefined term. But if we analyze the denominator, difference of 2 square, x minus 5, x plus 5, x plus 5 in the numerator, reduce it with the denominator, substitute every x with negative 5, negative 5, negative 5, it is 10. Then the answer is negative 1 over 10. Choice B. Question number 24. Limit when x approach to 2 for 3x minus 6 over x power 2 minus 4. Substitute x directly, 6 minus 6, 0 over 2 power 2, 4 minus 4, 0. But if we factorize the numerator by 3, then I'll get 3 times x minus 2 over, analyze difference of 2 square, reduce x minus 2 with x minus 2, substitute every x with 2, then the numerator will be 4, 2 plus 2, 4, 3 over 4, choice A. Question number 25. Limit when x approach to negative 2 for x power 2 minus 4 over x plus 2. Also, we will analyze the numerator, difference of 2 square, and reduce x plus 2 with x plus 2, substitute every x with negative 2, negative 2, negative 2, it is negative 4, choice C. See you next lesson.